Welcome, everybody. Woo, I like that. So my name's Jase. I'm what is my title now? Senior user advocate for Perforce, and I'm here to do a presentation about leveling up from either an indie studio who has Perforce set up but isn't utilizing it to its full potential yet, or someone who's working as more of a junior or intermediate developer and they want to start to work their way up to being in more senior positions, understanding the workflow better, how to maintain quality code, things like that. So for this talk, I'm assuming that you already understand the basics of Perforce. If you don't, you're welcome to hang out, but some of it might seem a little confusing at first if you don't. Cool. So the agenda for today. First, we're going to talk a little bit about some best practices for your features, as well as how you set up your streams. My mic is cutting in and out. As well as how you set up your streams. And then we're going to look at the folder structure for the projects as well, and a little bit about P4 shelves. And then we're going to spend most of the time talking about code review, using P4 code review to set up pre and post submit code reviews or art asset reviews. And then at the end, if we have time, I'm going to spend a little bit of time talking about some cost saving tips for a cloud server. So with that, let's get into it. I did want to let you know that I'll show this QR code at the end as well, but various links to resources that I'll be talking about in the presentation, they're all linked from here, as well as my information if you have follow-up questions and want to talk about any of those. So again, I'll show this at the end as well, and I'll also have a PDF of the slides in there as well. All right, so the main thing I want to drive home here when it comes to working in streams and branches, and if you come from a Git background, this is the biggest mental shift to make. And that is that the best practice is to all work in the same stream as much as possible. So everybody working in the same branch as much as possible. If you think about Epic Games, when they're making Fortnite, all of them submit directly into the master branch. They all submit straight into main. And then they have some other systems for integrating changes as they're preparing for releases. Like that's where they'll use streams, but they actually all work in the same place. The idea is that we want to find problems early so we can fix problems early, rather than doing months of development on a side feature, and then you have the horrible time of trying to integrate that with everything else. So what are streams? Why are they useful? If you're not using streams, if you're still using classic depots, also called local depots, now's the time to change your ways. Switch to streams. There's just a lot of very powerful features that you can get when you're using streams, as well as making things easier for your users. So what are streams? A stream is a branch, except when it's not. And we'll talk about that in a second here. But you could think of these just like branches if you're used to that concept. Also, a stream defines a workspace view. So this means that you can define which parts of the project are actually part of your workspace. And you can define that in a stream so that when a user comes and just picks that stream to work in, they get those files rather than every single user having to decide that for themselves. Streams enforce merging rules. So you can see here that we have these up and down arrows where these release streams are set to only allow you to merge down to main, while from development, you can go up and down. They help to enforce those relationships, but if you need to break those rules, you can. You do have that power. And then streams have superpowers, and that is that they can do things like importing from other depots, from other streams, doing sparse streams so that you can make task streams when you need to very quickly, very efficiently, and without taking up as much space. And then we also have virtual streams, which are these ones at the bottom, which I want to talk about in just a little bit. So starting off with streams, this is my recommended stream setup when you're getting started. That's it. Just one mainline stream. Everybody works in that. Great. If you get to a point where you want to separate a more stable working version of your project from the work in progress, then simplest way is to just make one development stream underneath your main stream. And so everybody works here in development, and then periodically when the game is working or when the animation project is in a stable state, you copy it up into main so that at any point, someone, say they need to do a demo to an investor, or they need to do QA or something like that, they have a stable working version in main. And it's okay if you break stuff a little bit in development until you move stuff up into main. So work is done in the dev stream and then copied up into main when it's stable for QA or demos or whatever it is. Then you can also make release streams. So a release stream comes off of main usually, and this is to say, yeah, this is our version 1. So this is assuming you're not doing, well, you can do this with rolling release. That's kind of how Epic does it with Fortnite. But the idea is that you have this release here, and then let's say we make another release. Now we can put that one over here. And this means that if we ever need to go back and fix bugs in those individual releases, we're able to still go back, get that state, make those changes, and then merge that down into mainline. So if that applies to you, release streams can be very useful for that. And then we have my favorite feature, which is virtual streams. So remember when I said a stream is a branch, except when it's not? A virtual stream is a child of another stream. So here it's the development stream, and then we have these virtual streams. When you're in those virtual streams, you're actually still in the same branch as development. So you're actually, it's just like you're working in development, but you're able to filter down a smaller view of that. So here's an example of what this looks like. So I have these 3 virtual streams over here, and you can see I have this Blender DCC folder and import meshes. And now I switch to a different virtual stream. I have the Unreal project, the engine, and the imports. I switch to a different, or now I switch to the main, and I have everything. I have the project, all of my DCC folders, my engine folder, all of my imports. And you can see I can loop back around. Now I'm just being the audio artist, so I only have one folder inside of DCC and just my music and sound effects. But all of us are working in the same stream on the same files. We just get filtered views because my sound artists don't need everything else, right? My 3D artists don't need everything else. So this allows you to more efficiently allow people to work on just the files they need, but you don't have to merge later because they're all actually working in that same branch, in that same stream. All right, let's talk about folder structure a little bit. So I've heard this called the Epic native folder structure. I've also heard it called folder structure. And basically it's just that your engine directory and your project directory should be side by side. They should be siblings of each other, not inside of each other, not inside extra subfolders. So right in your root, you have your engine. If you're customizing the engine, if you're not, don't worry about it. But then have a project folder, and inside of there is your U project and content and plugins and all of that. Now, what I recommend is also adding a folder for your DCC tools. So this is where you can have your Maya, Photoshop, Blender, Marvelous Designer, whatever it is, Substance, whatever you're using, in a DCC folder, organized however you want. Could be organized by which character, which prop it is, or it could be organized by department, whatever works for you. And then to have an imports folder. You could also call it a raw assets folder. And this is where you would put things like your FBX exports, your Alembics, your PNGs of your textures, that sort of stuff. Now, by having all of this in one place, as you saw before with those virtual streams, it allows us to give each department just the files they need. Or you could even make separate virtual streams for every single employee if you wanted to. Every single team member could have their own custom virtual stream if you wanted. So you have a lot of flexibility by just having a very simple structure here and then customizing with virtual streams. Okay, now let's get to the part where we're going to talk about code review. So first of all, who here is familiar with shelving in P4? Okay, good. We have a decent number. So for those who are not, let me show you what this is. So I'm working on this file here in Unreal, and I'm just going to make a change to this camera, move it a little bit closer to the character, and I'll compile and save. Now, you're familiar that I can check this out, And I could just open up my revision and submit it. But instead, what I can do is come in here and I'll see in P4V, I have my file that's been modified. Instead of submitting it, I can shelve it. And shelving is kind of thought of like stashing, but it also puts it on the server, which means that other people can access it. So here I'm shelving it, giving a description, and now you see it's made a numbered change list with shelved files inside of it. So now I'm going to switch to a different user. So let me go here. So now I'm a different user. I put it in dark mode so you can tell, different user. And in my pending change lists tab, if I check this one that says show only change lists with shelved files and remove the user filter, I can see that other users shelved files. And then I can come and unshelve those into my own workspace so that I could review them or check them before they're actually submitted. So everyone else isn't getting this, only people who go to that shelf and unshelve those files. So you'll see now it's in my default change list because I've unshelved that. And then I can open up the project and give Unreal a second to load. Here we are. And now if I go and check out that blueprint, I can see that in the viewport, I can see that value here has been changed to the closer camera. It's set to 300 now instead of 400. So this is kind of the manual way that you can do code reviews, is by shelving something, telling someone else, hey, I shelved this. It's on change list number 5 or number 863, whatever it is. They can unshelve that change, check it out, and tell you if it's good or not, right? You could even just use it to like send secret messages to each other, except it's not secret because everything's, saved in Perforce. Okay, so now how can we do that better? And this is where we use Helix Swarm, which is now called P4 Code Review. So if you ever hear code review, it means Swarm. Code review is just the new name, so it's simpler. Just says what it does. So within Swarm, and this is free, by the way. Code review is free. You can download it. It just extends your Perforce server, and it adds basically a review functionality, kind of like pull requests, if you're familiar with that in Git workflows. And you can set up 2 different types of reviews. We can do pre-commit reviews, which are kind of like what we saw, where it's shelved first and reviewed before it gets submitted. And then we also have post-commit reviews, which is where it gets submitted, everyone can see it, but we still want to review it after the fact. So with pre-commit reviews, we review the shelves before they're submitted. This ensures that the code base remains stable and that someone doesn't make some breaking change that then everybody else gets and everyone's in trouble now. You can integrate it with automated tests and automated builds, which I highly recommend. We'll cover that a little bit later today. And then generally it produces higher quality code. However, it can be a bottleneck. If your review process is slow, if you don't have enough reviewers, this can slow you down a little bit, right? Because you're not submitting directly, you need to get it approved first. So there's kind of the trade-off. This, though, is especially good for code changes, for essential functionality blueprints like gameplay that's going to affect many other things in the game, and plugins as well. On the other hand, we have post-commit reviews. With these, we submit, it goes into the depot, into the stream, and then you review after the fact. It's fast because you just get to submit right away and review later. You can also create reviews anytime later on if you want to. You could go back and say, hey, you know what? This thing that was submitted a month ago, let's make a review for it. Let's actually check that and decide what we want to do. It, however, doesn't give you the ability to test things first, right? You just submit them and they're in there. So again, it could break things. And if you do find a problem, it can be more difficult to undo that if now a bunch of people have made changes based on your changes to work around it or something like that. But it's a good fit for art teams. So if you think about a character design or something like that changes, that's generally not going to break a lot of things in the rest of the game for people. And we might review it and adjust it, but that's okay to do later. So we can see both use cases have different advantages. For code review, let's create a project. Take you through this. So it's a web interface. So you just log in. It's all your same usernames as you use in Helix Core and P4. And we have this interface here. We can just go to projects on the left. You'll see I have no projects right now. So I'll add one. And we'll call this our Bali, Unreal Fest Bali project. And in here, you can see we can do things like add members to it. So for example, I have a group that I've set up in P4. So again, same groups, same users you already have and already are using. I'll add my developers group to this. I can add other owners. So by default, I'll be the owner because I made this project, but you could also give other people the power to be an owner who can add other people to the group. I can set up default reviewers. So those are the people who will get notified by default of new reviews. And then I can also add followers, which are people who are not part of the project, but who want to see what's going on. So like a producer, something like that. Then we add branches. And what branch means here is actually just any depot path. So in this case, I'm going to go to my depot view in P4V. So from my workspace, I can go show in depot tree. And I can see my depot here, and I'll just copy the path from the top of P4V here. And I'll go in and paste this into code review with the ... to be recursive. Anything inside of this folder is going to be part of this project. And you can see I can set up some various settings. We'll come back to all this later. And yeah, same with workflows, minimum reviews, all of this we're going to set up in a little bit. We can set up automated tests, automated deployments. I'll get to this a little bit more later as well. And then we have, again, workflows, things like that. We'll come back to this. So now that I've made this project, if I just come back and I'll need to refresh. In the project, there's this files on the left side. And you'll see that that main branch that I made, that I defined, I now have that in files. And I can navigate in here and I can see all those folders I mentioned before. I can see all of those files. See, it's mirroring exactly the same folders, the same files that I have on my depot. And so now let's be a little more specific. So we just did main with everything in it, but let's actually break it up between code and art. So for code, this is going to be inside of my Unreal project. I'm going to want the source directory. And so I'll just, again, grab that path, copy it, paste it in here with the ... and I can do multiple lines. So let's pretend we have a plugins directory as well. I don't in this project, but let's pretend. So I've got plugins there. So anything that's inside of those paths is going to be part of this branch, which means we get to apply custom rules to it. So now you can see under code, when I click into here and look through the files, if I go into this Unreal project, all I have is that source folder. So again, this is not affecting the files on the depot, but just what I have access to here in my project. So now let's go, we're going to make another branch. And this one will be for everything else, basically. So this will be everything else that's in our project that's not in the source directory and not in the plugins directory. And you might customize this differently, have more branches if you want. So in this case, I'll say main, everything, but then I'll put a minus and put the paths to things that I don't want. So that's the other way you could approach this. So I'm going to say I want everything in Bali main, but I don't want anything that's inside of the source directory, and I don't want anything that's inside of the plugins directory. So now I'll confirm that. And if we go check out that file menu again, you see I have my two different branches here, art and code. And inside of art, I can click through. Now I have all of the other folders. And if I go into here, you'll notice though I'm missing the source folder. So that's not being included in this particular branch. So now you're probably asking, so what? Why do I care? What's the point? And so that's where we can make workflows so that we can set rules for how each of those branches are treated. Come in here, we go to the workflows tab. I'll click workflows and it's going to make a new workflow. And let's start by making one for code. So I'll say pre-commit code. So Remember, pre-commit is we're going to review it before it gets submitted into the depot. So under rules, if someone tries to submit without a review, by default it will allow, but I'm going to say reject. So you can't submit this if it doesn't have a review. I'm also going to say you can't submit this even if you do have a review if it's not approved. And then you can see I can also do some things like, can you still make changes to a review after it's been approved, things like that. I'm going to leave those alone for right now, but you can click this little question mark box and it'll take you to documentation about more of those features. And for this, I'm not going to automatically approve reviews. I'm not going to add a test yet. We'll do that in a little bit. And then I'll save. So now, oh, sorry, I just want to mention shared with others. It just means other people can put it in their projects as well. So if you have a useful one, you can click that so other people can do it. Okay, now let's make another one, and this will be for our art. So that's a post-commit art review. So in this case, we do want people to be able to submit without a review, but when they do, it's going to automatically create a review for them. And same thing, commit with a review. That's allowed because we're just allowing that. Yeah, so we'll just keep that on allow. And what we will do for this one is automatically approve, just so you can see how it works. Let's do automatically approve based on vote count. So basically, if enough people vote it up, it gets approved. So that can also be useful if you don't have a supervisor, but just a team that wants to review each other's work. You can, so like if 2 people say thumbs up, then it gets approved. So now in our settings for our branches, we can choose this post-commit art for our code branch, or for our art branch. And then we can set up this pre-commit code for our branch that has code in it. And we can also set like a minimum number of upvotes, things like that. So now that we have those rules in place, and we can double check, make sure that all saved properly. And now that we have those rules in place, let's see what happens. So I'm a user, and what happens now if I make a code change and try to submit? So let's open up some code, JetBrains Rider here, but this would be the same in anything else. I'm going to make a change to this walk speed. So that's going to prompt me to check out my file, and I'll change that from 700 to 800 for the walk speed. This is obviously a very small change, very simple change, but you could imagine it could be something more complicated. And now watch what happens when I try to submit this from P4V. You'll see this is inside the source folder, and that's where we have our rules set up. So I'm just going to say here that I increased the walk speed. And when I try to submit, I get this error message, and it says, must be associated with a review. So this says, hey, you can't do that. Sorry, you can't do it. And so it'll just be sitting there. But now what I can do is, because Swarm or Code Review and P4V are integrated, I can create a review directly by right-clicking and choosing Create New Review. I could add custom reviewers, special groups if I wanted to. I can choose whether or not I want to revert the files when I do it. I've got a lot of options here. I can say don't submit things that haven't changed. And when I submit it, and now in Swarm, I have this review page, and it nicely shows me my diff here of what I changed between the old version and the new version. And I can leave inline comments either on the whole thing. I can leave review comments on the whole review, or individual ones on individual lines in those files. So here I'll say split the difference. That was too much. 800's too fast. Let's make it a little bit less than that. And so I made that comment. I tagged it as a task. And so now in my review over on the right side, I have my tasks, and I can open this up and I see I have this task to split the difference. So now I can come in as the user and say, okay, let me unshelve those files. And now I'll open it back up. I'll make that change. I'll say now it's going to be 750 instead. And I'll just save that, come back into P4V. And in P4V, now when I right click, not on the file, but on the change list, I already have a review. So now I have this update Swarm review option. So I'm going to say update form review. And now if I refresh this page, I have my version 2 of this review. So this also means that you kind of have like a sub version control within your review before it's submitted to the main version control. And you can see I can compare version 1 and version 2, or I can go and compare it to the original base version. So I can go in and I can see those comments. I can look at the task. I can mark it as done. And I can see that status change, decide everything's good. And then when I approve it, it's now done. It's approved, and it's also been submitted for me. So I didn't even have to go back and submit it after that. In this case, I can just come here and I'm switching to a different user because I can't approve my own review. So I switched to a different user here. And so I'm coming in, looking at the different versions of it. Let's compare version 1 to version 2. Split the difference, looks good. I can even mark this task as confirmed, like verify. Yep, I agree, the task was done. And then I can see tasks all complete, great. Now I can thumbs up and I can change the state to either just approve, which would allow them to submit, or I can approve and commit. And when I do that, there's this checkbox here that will delete the other pending change list when I submit this one. So essentially that allows me to submit on their behalf. So it'll still be a submit from that user in the history, but I'm able to do that for them as the reviewer. And so now as that user, I see my change list is gone. I see this now needs to be updated. So I come up and say get latest so that I can get the latest changes, which are my changes actually. Great, and we can see there it is, 750. Okay, so now let's take a look at how this would work with an art asset or something else that's not code. So in this case, I'll just move this little platform a little bit, check that out. And now let's go and let's change the time of day, right? There we go. Much more dramatic look for our game here. And yep, check out all of those things. And now, if I go in here and submit those, I'll just view my changes right here inside of Unreal, and I can submit those. And because none of these are in our code branch where we have that pre-commit rule set up, this will allow me to submit. So I can say, yep, I raised the platform and I made the sun lower. Great. Let's submit and validate. Yes, everything validated. Great. Cool. And now when we go back into code review, I keep wanting to call it Swarm, code review. If we go here, let's hit refresh, and we can see that now we have a new review. Because remember, for art, we said when you submit without a review, make one for me. So in this case, it created a review, and I can come in here and look at it. But these are UAsset files, right? These are binary files. So I can't view a diff of them right here inside of the web browser. So instead, to review this, I've got a couple options. One is I could unshelve those like you saw, take a look at them. Or as the person who submitted this, I could take a screenshot. And so in this, like, let's just choose a file that I have of a screenshot of this, post that. If it's something that's that easy to review, you could do that. I actually just talked to someone who I think in the next month or so is going to open source their tool to view blueprints in Swarm, which is pretty exciting. Look forward to that. Right, so now a reviewer could come along and see, okay, oh, I see they have comments. Oh, okay, let me look at this picture. Yeah, I think that looks good. Or maybe they could give some extra notes or something like that. And, you know, I can like it, do those sorts of things. You can also put emoji in your comments, which a lot of people like. And so now I can come up here, and if I click thumbs up, you'll notice it's approved all of a sudden, magically, because we set this one to say, if you have enough upvotes, it just gets approved automatically. And all the same stuff applies. I could make tasks, things like that, if I needed the artist to make changes. Okay, so now we're back in Unreal, and I want to show you a feature that was added in 5.3 and basically nobody talked about, or at least I didn't find out about it till just recently. So to demo this, I'm going to make some changes to a blueprint here. So I'm just going to add a print statement. I'm going to keep this super simple. I don't need to do anything crazy. I'll check this out. And let's make one more change over here. Let's just add another node off the end. And what's something simple? How about we do add component? Let's add some audio curve, whatever. I'm just going to add something at the end here and save that. And now when we come to submit this, I'll show you two different ways. So the first way is I check it. Yep, everything looks good. And I'm going to submit these changes just like we did. And okay, come in here and I say, yes, that change looks good. Let's submit. And we'll say we updated the blueprint. Okay, and we'll submit. Yes, validated, great. So remember that when we look at this in Swarm, we're not able to review the blueprint in Swarm, right? Because it's your updated blueprint, there it is. But I can't view that here in Swarm. And so it could be difficult for me to tell what changed. And that's where this new feature in Unreal comes in. So if I notice here, this happened on change list 91. So not the review number, but the change list number. So if I copy that, I come back into Unreal. Under revision control, there's this review change list button. And I can just type in that number here and hit load. It pulls in that change list, shows me all the files that were in it, and it gives me this option to diff over here on the right. So now as the reviewer, I can actually see what changed by opening up this nice visual diff that Unreal has for blueprints. So I can see, I can look at all my different settings, but this one that's highlighted, the event graph, shows me what I actually changed between the two. So as the reviewer, this makes your job a lot easier to actually go through and see, okay, yeah, that's what changed. That's what it was, rather than you just having to remember what it was like beforehand. And so the other neat thing is that there's this ability to add comments directly inside of this blueprint view. And it stores those in P4 code review, and it puts some extra metadata on them so that they show up in the right place inside of Unreal. So this is a pretty neat little feature. So I added that as a task. If I come back into Swarm and I look at my tasks, I can now see I have this task to remove that extra node that I added. And you'll see it has this little UE metadata section. That's telling Unreal where that comment belongs. So now if I come back into Unreal, and let's say now I'm the person who received the comment, I'll load that same change list. I can see I have a comment. And when I go to diff it, when I open up that event graph section, I can see that directly in place there. So I'm actually able to give the feedback where you want it. So kind of like the inline comments we saw with code, but inside of your blueprints too. And so I can come here, I can go, address that change. And now I want to show you the other way. So we did a submit and then reviewed after the fact. Even if you don't have that rule, I could choose, instead of doing that, to come into P4V and submit a review, just like I did before. So now I'm going to request a new Swarm review instead of just submitting this change. And maybe I'll make a little comment that says, here's what I did, and I want input on it. I want someone to give me some feedback on this before I submit it. And so in that case, I can create that review. Here it is in Swarm. And again, all I have to do is note this change list number, which in this case here looks like 93, I think. Yeah, 93. And then if I come into Unreal and I do that same review change list option that I showed you, I can put in a change list. Sorry, it's actually 92, not 93. 92 is the change list number. You'll see here, I still have the change, right? It hasn't updated yet. But if I close this and I come down to that review change list button, hit that, and I'll put in 92 now, because I know that's the change list that I want, 92. And I'll load that. And now I'm able to diff this blueprint, even though it hasn't been submitted yet, right? So I'm able to actually check those changes, again, visually see, okay, that's what changed. That node is gone now. I see in the event graph, that's all it was. Great, I can go ahead and I can approve that. Okay. So now let's talk just briefly about automating tests and builds. So inside of Swarm, we have tests down at the bottom, and we can create new tests. And these are tests, but they really could be anything you want, because all it's doing is it's calling a request URL. You can add a description. You can share it with others, just like we could with our workflows. You put in a URL, and then it's going to have a timeout for when it gets approval for that. So not to run, but just to acknowledge that it received the request. And then in the body here, you can send this as URL encoded, JSON encoded, or XML encoded. And you have this list of all these variables that you can send in. And that's things like the change list number, the user, the change list description, and you can pass in callback URLs. So I'll show you this one I already set up here. So this is my test webhook, and I'm passing in an update callback URL. I'm passing in the description. You can also pass in the change list number, probably an important one, so that it knows what to unshelve to do the build. And what it's going to do is it's going to call back to this update. So once it's run all the tests, it calls back to that update URL with some JSON telling it what the status should be, what messages there should be, all of that. And you can run multiple of these. So you could have lots of different builds and tests all going on, and you can choose if that blocks things or not. So if I go back to my branch settings, if we go into our code branch that we set up earlier, we can come here and see that pre-commit code. That's our workflow. So let's go to that workflow and pre-commit code. We'll check it out. And under tests, we can say add test. And now we can choose that test build or that demo build that I created. We can say when it runs. Is it on update? Is it on submit? Or is it on demand? You could also just manually trigger builds if you want, or tests. So I'll say on update, and I'm going to say that if this fails, it's going to block approval. So you can't approve this until the test is passed. So then I'll just hit save. And now let's go back to our project here, and let's make another change inside this code file so that we can trigger this test to run. We'll change this braking, deceleration, walking, and we'll change this to a different number here. We'll save. We'll come back into here and let's submit a review. So right click, request swarm review. And I'll just say changed the braking speed. I just made a change to the stopping speed. Okay, there we go. And I'll request a review. Now we can see this. And on the right side, when I refresh, I will see the tests, and I'll see that my test passed. So I just wrote a quick thing that's going to very quickly validate this. I'll see that test passed. Great, it looks good. This message here that says build completed with status pass, I could actually send back anything I wanted. So I could send much more detailed information about how long it took, or any warnings or anything like that that came up. And then I'll come here and I'll say, let's approve it, and we'll commit it, and I'll delete the change list while I do it. And there you have it. So now let's do something else. Let's break it. Let's do something bad. So here we are. I'll get latest, and then we'll jump back into that file, and let's come down here and we'll add something bad. So we'll check out the file, and we'll add something broken, and let's pass in a look axis vector, z-axis. You can see here JetBrains Rider already knows this is bad, and it's highlighted it for me, but let's pretend I didn't pay attention to that. I didn't know what I was doing. I'm just going to go ahead and I'll submit this review. So I'll request a new review. I'll say, I don't know what I'm doing, and I'm going to submit a review. And now you'll see the build is running, the test is running. I can see here it's in progress. And then after a little while, once it's finished, I'll refresh, and you see it failed. So that's marked that this has failed. Again, I could customize what message comes back. Mine just right now says it failed. And then I can go in here and I can't approve it because it failed, right? So it won't let me approve this, but I can go here and I could either request review or I could just reject the whole thing and say, you're fired. We're not going to take your changes. All right, so just thinking ahead to further possibilities that you can do after this. One is that there's a Jira integration that's built in with code review so that you can have it match up with your Jira tickets, update statuses there. There's also a Team City integration. You can also integrate with Horde. Horde has a nice Swagger API. Swarm also has an API, so you can talk back and forth between the two of those. There's a Jenkins integration if you do your builds with that. And as I mentioned, there's an API. So you can do all sorts of things with this. You can build your own custom tools. I actually think a neat one after watching some talks today that came to my mind was using Unreal Insights to get metrics that you'd have to run and then could submit those along with a review so that you can see if metrics have changed over time. There's lots of cool possibilities like that. And you can do all of that from the REST API because the Swarm interface you saw uses the same API that's available to you. So literally anything that you can do in Swarm, you can do with the API as well. Okay, we have a little bit of time left, so I'm going to talk about saving money if you have a server in the cloud. Okay, big change of thinking. Okay, so first thing is I want to tell everyone about the server deployment package. So what the server deployment package is, and there's a link here, but that's also on that resources page that I have the QR code for that I'll show in a sec again. The server deployment package is basically a whole group of scripts that make it much easier to install servers, to upgrade servers. It pre-configures them with best practices security settings. It does offline checkpoints, so much more performant checkpointing, automatically schedules that to happen nightly, puts it all in individually partitioned drives that you mount to your machine. So if you've used any of our cloud templates, like we have a template in the marketplace on AWS, that's already using the SDP under the hood. But this is totally free, accessible, available to anyone to use yourselves as well. So if you're adminning a server, this might save you a bunch of time by setting up your server using this. Or if you already have your server configured, you could check this out to just see how are they doing things. Okay, let me implement that myself as well. Next is consider your storage volume types. So SSD is the fastest, but it's also the most expensive, right? So if you're storing everything in SSD, as your project grows, it can end up being pretty expensive in the cloud. So SSD, because it's fast, and especially because it's fast at random read-write, you definitely want your database, so your metadata and your logs, you all want those to be stored on SSD. So generally what we do, and the server deployment package I mentioned does this, where you'll mount 3 separate volumes to your instance. You'll have one volume that's for metadata, which is the database. You have another volume that's for logs, and you'll have a third volume that's for the depot data or the file data itself. And that's the one that's going to be huge. So keep your metadata and your logs on SSD, but those are relatively small, right? There's like a few kilobytes per version per file in your depot. So they're quite small. Then you can use a spinning disk. So like on AWS, this is the difference between GP2 or GP3. And then ST1 is what they call it. But Azure, Google, all the cloud providers have something similar. So spinning disk hard drive is generally pretty good at linear throughput, but it's not very fast at random read-write. So if we're putting your file data on here, hard drive can save you a good chunk of money because it's usually about half the price of the same amount of storage in a solid-state drive. And then the third thing is S3. Or object storage. So S3 is much slower than the other two. It's also much cheaper. So it is possible in Helix Core, or P4, I should say, In P4, you can configure your depots to use S3 on the back end. However, for performance, I think you might notice a difference there. But if you use it for archive depots, which is a feature in P4 where you can archive files to a different location that can be cheaper or that you could snapshot, store somewhere else, you could use S3 to archive things away so that you free up space on your main drive where you have all the files and store those in S3 for a much cheaper price. All right, and then egress costs, right? This is, for anyone who's worked with servers in the cloud, this is probably where you ended up paying more money than you expected, is that all the cloud providers, it's free to put data into them, and every single byte of data you get out, they charge you money for. So, yeah, every time you sync, you're getting charged money for that, right? Sometimes they'll have a certain amount they give you for free, but then over that, it can cost money. Where I've especially seen this cost people a lot of money is if they have a build, like a build automation that wipes the workspace and resyncs everything every single time it does a build. That can really quickly add up because you're doing that full egress cost of your whole project every single time a build or a test is triggered. So that's one thing to consider. And oftentimes, just using a P4 proxy is enough to solve this problem. So if you have your server in the cloud, and then you set up a P4 proxy server that's on-premise in your office or somewhere else that people can access, and basically the proxy server connects to the main server, and then the users connect to that proxy server instead of connecting to the main server. So when they're setting up P4V or their integration, they would instead point to the address of the proxy, not to the actual server. And then whoever requests a file first, that file gets cached on the proxy server. And then anyone else who requests that same file, it'll just download straight from that proxy server. So you'll get the files a lot faster, and you won't get charged egress more than once per file, per file that gets downloaded, because it's being cached. So when we did Project Titan last year, if any of you are familiar with that, we had 3,000 people from around the world. To keep that infrastructure simple, we had a main commit server that was based in London on AWS. So AWS in London was the commit server. And then also on AWS, we had proxy servers that we had, I think, one in, where was it, Seoul, or was it Australia? I forget. We had somewhere kind of in this time zone. We had one that was like US West Coast, one US East Coast, and that people could that closest proxy to them. And even that helped improve performance because using their, home internet or their business internet, they were able to connect to that proxy. But then that proxy is using AWS's own network to communicate back to that master server. And so it has much more of a direct line, has better performance. So proxies can be super useful, and they're really, really easy because you don't need to back up a proxy. You could delete your proxy and make a new one. Every single user could make a proxy on their own computer if they want. I don't think that would help you very much, but you can, right? They're very easy, doesn't require a lot of extra setup. So definitely worth checking that out. And yeah, usually a proxy is all you need. So try that. It will not solve your problem with submitting, though. So if you're working with a company where they have a server in the US or in Europe, and you have really bad latency connecting to them, this will not help with your submits. So in that case, that's when you would want to go to an edge server so that you can submit locally, and then it can transfer to the main server in the background. I'm not going to cover that in this talk, but just to help you understand when one might help or the other. If it's a question of bandwidth, P4 proxy is what you need. If it's a question of latency, then an edge might be a better solution. And now that resources page again, I have lots of links on there as well as PDF of many of these slides. Resources, feel free to reach out, ask questions. I have a link on there to my GitHub where I post a lot of free tools and things that you can incorporate into P4V or use with Unreal Engine. So please go check that out. Connect with me on LinkedIn. Happy to connect with all of you. And thank you all so much.